Alright, so you're telling me ChatGPT is worth billions of dollars, and I'm about to show you how to clone it in less time than it takes to microwave popcorn? Challenge accepted. By the end of this video, you'll have your own working AI chatbot that your friends will think took you weeks to build. But here's the secret, we're doing this in 15 minutes flat. No BS, no 40-minute intros, just pure coding action. Let's forge some code. First things first, we need to set up our project. I'm using Vite because it's lightning fast, unlike Create React app which takes longer to start than my morning coffee routine. Open your terminal and let's get this party started. Here's the command to create our React project with Vite. We're calling it Chat Clone because creativity is my middle name. This will scaffold our entire project structure in seconds. 3 terminal commands that create a new React project using Vite template, navigate into the project directory, and install all necessary dependencies. The first command uses npm's create command with Vite's latest version, specifying React as the template. The second command changes directory into our newly created project folder. The third command runs npm install to download and install all the dependencies listed in package.json. Now let's install the packages we need. We're grabbing OpenAI's official SDK for the API integration, Axios for HTTP requests, and React icons for some slick UI elements. Run these commands and watch the magic happen. These are our core dependencies. OpenAI is obviously the star of the show, it's what lets us talk to GPT. Axios handles our API calls smoothly, and React icons gives us those nice UI icons without bloating our bundle. Single npm install command that adds 3 packages to our project, OpenAI, the official OpenAI SDK for JavaScript that provides easy access to GPT models, Axios, a popular HTTP client for making API requests with better error handling than Fetch, and React icons, a library providing thousands of popular icon sets as React components. These packages will be added to our package.json dependencies. Time to build our chat interface. We're going for that clean, modern ChatGPT look. Think dark mode, smooth animations, and a layout so crisp it could cut diamonds. Let's start with our main app component. Here's our app component structure. We're importing useState for managing our messages and loading state, and useEffect for any side effects. This is the brain of our chatbot, where all the magic coordination happens. Complete app component imports and initial structure. We import useState to create state variables for messages array, stores conversation history, input string, tracks user's current message, and loading boolean, shows when AI is thinking. We import Axios for API calls, FiSend icon for the send button, ByBot and ByUser icons to distinguish between AI and user messages. The component returns a basic container div with a heading. This is our foundation that we'll build upon. Now we need to render our messages. Each message needs to show who sent it, the user or the AI, with different styling for each. We'll map through our messages array and display them beautifully. This is our message rendering logic. We map through each message in our state, displaying them with appropriate icons and styling. User messages get the user icon, AI messages get the bot icon. The key prop helps React efficiently update the list. Message rendering section of our app component. The return statement creates the main container with a header showing our app title. The messages container div holds all chat messages. We use the map function to iterate through the messages array, where each message object contains role, user or assistant, and content, the actual text. For each message, we create a div with dynamic class name based on role, add the appropriate icon, ByUser for user, ByBot for AI, and display the message content. Below the messages, we conditionally render a loading indicator with 3 animated dots when the loading state is true, showing the AI is thinking. Time for the input form. This is where users type their messages. We handle the form submission, prevent default page reload, and trigger our API call. Simple but crucial. Input form section of our component. The form element has an onSubmit handler that calls handleSend function, we'll create next. Inside, we have a controlled input where value is bound to our input state and onChange updates it using setInput. The placeholder provides user guidance. The input is disabled when loading is true to prevent multiple submissions. The submit button contains the FISN icon and is disabled when loading or when input is empty, using trim to check for whitespace only input. This ensures users can't submit empty messages or spam the API. Now for the exciting part, connecting to OpenAI's API. This is where our clone actually becomes intelligent. We'll create a function that sends user messages to GPT and gets responses back. But first, you'll need an API key from OpenAI. Head to platform.openai.com, create an account, and grab your key. Here's our handle send function, the heart of our chatbot. When the user hits send, we add their message to the chat, make an API call to OpenAI, and display the response. The API endpoint is set up on our backend for security. Never expose your API key in front-end code. Complete handle send function that manages the entire chat flow. First, we prevent default form submission and validate input isn't empty or loading. We create a user message object with role and content, add it to messages state using the spread operator to preserve previous messages, clear the input field, and set loading to true. Inside a try-catch block, we make a post request to our backend API endpoint, sending the full conversation history, previous messages plus the new user message. When we receive a response, we extract the AI's message from response.data.message and create an assistant message object. We add this to our messages state. If an error occurs, we catch it, log it for debugging, and show a user-friendly error message in the chat. The finally block ensures loading is set back to false regardless of success or failure, re-enabling the input form. We need a simple backend to keep our API key secure. Never, and I mean never, put your OpenAI API key in front-end code. Anyone can inspect your code and steal it. Let's create a quick Express server. Create a new folder for your backend, initialize it, and install the necessary packages. Express for the server, OpenAI SDK for API calls, Cores for handling cross-origin requests, and Doten for managing environment variables securely. For terminal commands to set up our backend. The mdir command creates a new directory called server for our backend code. The cd command changes into that directory. npm init quickly initializes a new node.js project with default settings, creating a package.json file. The final npm install command adds 4 packages: Express, minimal web framework for node.js to create our API server, OpenAI, official SDK for communicating with OpenAI's API, Cores, middleware to enable cross-origin resource sharing so our React app can communicate with this backend, and Doten, loads environment variables from a.env file to keep our API key secret. Here's our complete backend server. It's lean and mean, one endpoint that receives messages, forwards them to OpenAI, and sends back the response. We're using GPT 3.5 Turbo because it's fast and cheap, but you can use GPT-4 if you're feeling fancy. Complete Express backend server for our ChatGPT clone. We import Express for the web server, OpenAI SDK for API communication, Cores for cross-origin requests, and Doten for environment variables. After configuring Doten, we create an Express app and initialize OpenAI with our API key from process.env.openai_API_key, stored in a.env file. We enable Cores middleware to allow requests from our React app and Express.json middleware to parse JSON request bodies. The main/API/chatpost endpoint extracts messages from the request body, sends them to OpenAI's chat.completions.create method using the GPT 3.5 Turbo model with temperature 0.7, controls randomness, higher is more creative, waits for the response, and sends back the AI's message content. Error handling catches any API failures and returns a 500 status. Finally, we start the server on port 3001 with a console log confirmation. Create a.env file in your server folder and add your OpenAI API key. This file should never be committed to GitHub. Add it to your Git ignore immediately. Security first, folks. Your .env file should look like this. Replace your API key here with your actual OpenAI API key. Keep this file secret, keep it safe. Environment file that stores sensitive configuration. This file contains one variable, OpenAI_API_key, which holds your secret API key from OpenAI's platform. The .env package reads this file and makes the variable available as process.env.openai_API_key in our node.js code. This approach keeps secrets out of your source code. Important, add .env to your .gitignore file so it's never committed to version control, preventing your API key from being exposed publicly. Time to make this thing look gorgeous. We're going for that sleek ChatGPT aesthetic, dark theme, smooth gradients, and animations that make you say damn, that's smooth. Let's add our CSS. Here's the CSS that makes our clone look professional. Dark background, smooth shadows, and responsive design. The messages alternate styling based on whether they're from the user or AI. I've added smooth transitions and hover effects for that premium feel. First section of our CSS styling. We start with a universal selector reset, removing default margins, paddings, and setting box sizing to border box for consistent sizing. The body gets a modern sans serif font, dark background color #1A1A1A, and white text. The app container is centered with max width 900 px, full viewport height, and flexbox column layout to stack header, messages, and input vertically. The chat header has padding, a beautiful purple gradient background using linear gradient from #667EA to #764BA2 at 135 degrees, centered text, and a subtle shadow for depth. The messages container takes up remaining space. Flex 1 enables vertical scrolling with overflow auto, has padding, and a slightly lighter dark background #2A2A2A. Each message uses flexbox with gap for spacing, bottom margin for separation, and a slide-in animation for smooth appearance. Continued styling for message content, icons, and the typing indicator. User messages get a blue accent, AI messages get a purple accent. The typing animation is pure CSS magic, 3 dots bouncing in sequence. Continued CSS for message styling and animations. Message icons are sized at 24px with minimum width for alignment. User messages get blue icon color #667EA, assistant messages get purple #764BA2. Message content has dark gray background #3A3A3A, padding for comfort, rounded corners with border radius 12px, and line height 1.6 for readability. The typing indicator uses flexbox with 4px gaps and padding. Each indicator span is an 8px circle with purple background, created using width, height, border radius 50%, and a typing animation. The 3 spans have staggered animation delay values, zeros, 0.2s, 0.4s, creating a wave effect. The typing keyframes animation moves dots up 10px at 30% completion, creating a bounce. The slide-in animation fades elements in from opacity 0 and 20px below their final position for smooth message appearance. Final CSS for our input form. Sticky positioning at the bottom, flexbox layout, styled input with focus effects, and a disabled state for the button. This makes the whole interface feel polished and professional. Final CSS section for the input form. The form uses flexbox with 10px gap, padding on all sides, dark background matching messages container, and a subtle top border for separation. Position sticky with bottom 0 keeps it visible when scrolling. The input takes all available space. Flex 1 has comfortable padding, dark background, transparent border, becomes colored on focus, rounded corners, white text, and smooth transitions. The focus state removes default outline, adds blue border color, and slightly lightens background for visual feedback. The submit button has padding, gradient background matching the header, no border, rounded corners, white text, large icon size, pointer cursor, and transitions for transform and opacity. The hover state, only when not disabled, scales button to 1.05 for tactile feedback. The disabled state reduces opacity to 0.5 and shows not allowed cursor, indicating the button can't be clicked. We're in the home stretch. Let's fire up both the backend and frontend and watch our ChatGPT clone come to life. Open 2 terminal windows, one for the server, one for the React app. Start your backend server first. Navigate to the server folder and run node server.js. You should see the confirmation message that the server is running on port 3001. If you get any errors, double-check your .env file and make sure all packages are installed. Terminal commands to start the backend server. First command navigates to the server directory. Second command runs our server.js file with node.js, which starts the Express server, initializes the OpenAI client, and begins listening on port 3001. The comment shows the expected console output confirming the server is running. If the server doesn't start, common issues include missing.env file, incorrect API key format, missing node_modules, run npm install, or port 3001 already in use by another application. Now in a separate terminal, navigate to your React app folder and start the development server with npm run dev. Vite will spin up fast, and you'll get a localhost URL, usually localhost 5173. Click it or paste it in your browser. Terminal commands to start the React frontend. First command navigates to the chat-clone project directory. Second command runs the dev script defined in package.json, which starts Vite's development server. Vite is incredibly fast, typically starting in under a second. The comments show expected output. Vite confirms it's ready and provides the local URL where your app is running, usually port 5173. Open this URL in your browser to see your ChatGPT clone. The dev server includes hot module replacement, so changes you make to code will instantly reflect in the browser without full page reloads. Boom! There it is. Your very own ChatGPT clone running in the browser. Type a message, hit send, and watch as the AI responds just like the real thing. The typing animation shows when it's thinking, and messages flow smoothly into the chat. This is your creation, running live. Look at this transformation. From absolutely nothing to a fully functional AI chatbot in just 15 minutes. The before shows an empty project folder, and the after shows our beautiful, working chat interface with real AI responses. This is the power of modern web development. Here are some awesome ways to level up your clone. The possibilities are endless once you have this foundation. You could add a light/dark mode toggle for users who prefer bright themes. Message history with local storage means conversations persist between sessions. Different AI personalities by changing the system message sent to OpenAI. Code syntax highlighting for when the AI returns code snippets. Voice input using the Web Speech API for hands-free interaction. Export chat conversations to PDF or text files. And custom styling themes so users can personalize their experience. "15 minutes. One AI chatbot. Infinite possibilities." And that's a wrap. You just built a ChatGPT clone in 15 minutes. How insane is that? This isn't just a tutorial project, this is a portfolio piece, a foundation you can build on, and proof that you can create incredible things fast. Don't forget to grab the source code from the description, drop a screenshot of your clone in the comments, and let me know what you want to build next. Until next time, keep forging that code. Peace.